Namaskar. A very good afternoon to you all. Our Honorable Chief Guest, Dr. Madhavan Nair Rajeevan, Secretary, Ministry of Earth Sciences, dear students, the entire IISER Mohali family, distinguished guests, ladies and gentlemen. A warm welcome to all who have assembled here today to celebrate IISER Mohali's 11th Foundation Day, a little over 10 years into its existence. I understand that the foundation stone was laid by our then Honorable Prime Minister Monsoon Singh Ji in September 2006. I also understand that classes began in the autumn of 2007, exactly maybe this time. So, friends, happy birthday to IISER family. So this is a beautiful thing made by our dear Subrina Moli Mandal. Just about few minutes back, she came to our office and handed over this beautiful gift, and I am dedicating to all of you here and our IISER family and friends and our distinguished guest. So actually, this IISER Mohali, I have been coming this campus for last 2-3 years. This is my third visit, but on 18th September, as I joined as a director, earlier I came twice. And I've started witnessing the development of this place under the superb leadership of my predecessor, the hero of this campus, Professor N. Sattamurthy. So, happy birthday, and which is also, this campus is an embodiment of such Bharat, and nothing is so befitting today that our chief guest today, our guest of honor, Dr. Madhavan Sanjeevan, who is for his whole life working hard to, in different ways, to make our earth, Mother Earth, or our Mother India, or our every corners of our country neat and clean from all respect. It's a matter of real pride to all of us, friends. A special warm welcome now to our chief guest and Foundation Day speaker, Sir Dr. Madhavan Nair Rajeevan. A warm welcome also to all the assembled dignitaries, guests, heads of the institution from around the Tri-City. I have not yet met everyone. However, I'm sure that we are all going to get along extremely well. The warmest welcome and the felicitations of all are due to all the faculty, our staff and students of IISER who have helped to take this institute to a position of eminence and renown, both within the country as well as abroad. Today is our day after the glorious first decade of this institution. Although I have taken over as director on 18th September, I am only the latest to join this growing family of admirers and stakeholders of IISER. At this joyous juncture and the day of our worship of Ma Durga starts, I wish to recall and record my profound respect and deepest love for our most important hero, our beloved founder director, Professor N. Sattamurthy, popularly known as Sati, for his utter dedication, which led to an addiction, but for which today's event could not have been possible. Although he is physically not with us today, at this proud moment, on behalf of all of us, I do convey my warm salute, my gratitude, my deepest respect, and I wish that I learn from him both what and how he has performed in placing IISER Mohali with the fastest escape velocity into this amazing orbit of movement and dynamic progress. I'm also missing here the presence of our Honorable Chairperson, Dr. Madhu Chandakar, a renowned oncologist from Kolkata, whom I look forward to meeting soon. I'm still learning of your ways and of your practices and rituals and precepts, of your likes and dislikes and your hopes, fears and expectations from this great institution. With each discussion that I have with someone from IISER, I'm also slowly beginning to understand the expectations that you have from me. Of course, I'm yet to fully understand all that you have done, all that you have sacrificed, and all that you have not yet done and to be sacrificed, or which remains to be done. I'm also yet to conceive of the nitty-gritty details of how we should all go forward, march forward, together, minded together from this juncture in IISER's history and evolution. However, I can easily summarize exactly how I feel about my emotions and my own expectations, my own dream about how I wish you would all also feel on this important, auspicious occasion. My dear colleagues, please have no worries or no fears. Life is a playground, a merry-go-round, as well as a roller coaster. Some things improve, other things change, yet other things repeat and cycle and recycle. Here, I feel a little bit excited and also emotional to recall the words of the poet laureate I've been reading, learning since my childhood or high school, Alfred Lord Tennyson. From his poem about, the title is The Brook, which I am comparing to IISER Mohali, to quote him, and draw them all along and flow, to join the brimming river, for men may come and men may go, but I go on forever. IISER will go on forever, forever. The overall curve of our institute should be only one way, ever upwards and onwards. Here again, I have the honor and the liberty to recall our great Swami Vivekananda, who said, "Arise, awake, and stop, not till your goal is reached." And this is applicable to all of us. Become the best teacher that you can be, the best researcher that you can be, while being a great teacher, and the best colleague that you can be, while also being a very good researcher and a teacher together. But teaching and research goes shoulder to shoulder, the way basic science and applied science goes shoulder to shoulder. Not everyone to the same extent, of course. Just everyone in the same way, each trying their best. Just try and do your best and leave the rest. Just to politely remind you here all that which I have been following, I have been instructed since my childhood by all my mentors, teachers, colleagues, friends, parents, that there is no alternative to hard work. The rest will all sort itself out. That Hindi में कष्ट करने में किष्ट मिलता है. Here I would also like to recall a sloka from Upanishad. Gatassoka na kartabba bhavishyang naiva chintayet vartamanena kalena vartayante vichakhana. You know it. I think you all understand the meaning. Gatassoka na kartabba bhavishyang naiva chintayet. Present. Present. And of course, look for the future. Present, excellent, means future is assured, golden, or even more than that. Platinum. Here, friends, I do submit that speaking big things is very easy, but they can be very hard to implement. But at the same time, I firmly believe that nothing in this world is impossible, even if things are tough. 10 years is a long time, a time to look back and also a time to look forward. I understand that a little later today, the annual report for the period from April 2016 to March 2017 will be released. In that annual report, of which we have a few advance copies on the table, the remaining will be there in some weeks. Our founder director, Professor Satyamurthy has provided an excellent platform, an overview of IISER's journey of the first 10 years. It has been a remarkable journey. Word is not enough to explain, to justify just the fruit. Just like our honorable guest of honor planted these saplings. And I wish that if not the fruits, I can wait for the flowers. I came to know from our engineer, Srivastavji, that it may take 5 to 6 years. So I'm looking forward, if not the fruits. Fruits you will all enjoy, but at least I can help to flower, to blossom. From its humble beginnings in the transit campus in Chandigarh, where IISER managed to survive for quite some time with only a handful of faculty, some of whom I am very honored and lucky to witness and their arrival here and to interact with them in the beginning with the few BS/MS students, to the establishment of such a wide-ranging set of courses and curricula, and which led to a real amalgamation at this present moment, which is really needed for our country or for the whole world in a global level, which is something that I also had the opportunity to contribute, albeit in a very, very small way. To the initiation of the practice of admitting PhD and integrated PhD students some years after the beginning, to the first implementation of external agency-funded research projects at IISER, and all the way to this thriving campus of nearly 90 faculty, over 1,300 students, including 465 doctoral scholars, nearly 150 different research projects, heads, nearly 700 research publications, including some in the very best journals, and nearly 20 patents filed. 4 principal disciplines, 2 adjunct disciplines, 6 batches of graduated BS/MS students, graduate alumni who have already finished their PhDs here or elsewhere. I wish them all the best, and I also expect from all these distinguished alumni, please come back, join hands, so that we can grow and grow and grow to the limitless sky. Please, doctoral alumni who have already become faculty at 2 or 3 different institutions and some excellent research facilities. Research facilities, इनका क्या कहना है? Yeah, IISER has set up a research facilities which are comparable to those of the very best institutions, including several which have not just been bought, installed and mastered, but actually built up from scratch or integrated from multiple sources using invaluable expertise and experience. It has truly been a most remarkable journey to remind again and again. IISER Mohali has indeed managed to gather together formidable expertise in almost all the fields of modern maths, physics, chemistry, and biology, as well as earth and environmental sciences. It has been popular and thriving department of humanities and social sciences too, in an equal contributing manner. They are very, very important, as you know, languages and other things. Without them, we cannot communicate. Some of its departments are already arriving on the world scene with a bang, with papers published from work done here in journals published by the stubbles of Nature, Science and Cell. Not to forget the very best of journals published by reputed scientific societies and the world's most reputed science publishers. To take the most recent examples, I note that only during the last 3 months, Dr. K.P. Singh from Physics has published a full article in Nature Materials. I was fortunate to meet him, Dr. Singh, just a couple hours back, and I told him, I'm now waiting for Nature. He said, sir, don't put me under pressure. I said, never, never. No excellent science is done under pressure or under guarantee. It comes spontaneous, provided you have the mindset, which is very, very important. Young brother, you have the mindset. I am very confident you can do it, and all of us can do it, not only you, all of us. So that is what I am praying today. On the nanostructuring of spider silk, Dr. Shravan Mishra from Biology has published a full paper in the European Molecular Biology Organization journal on the functions of a protein involving in RNA splicing. To mention here, our Dr. Lolitika Mandal has been chosen for the most prestigious Senior Welcome DBT Fellowship. Prior to that, there have been quite a few other such stellar contributions in comparable journals. There can be no doubt that IISER Mohali is doing extremely well. And about this campus itself, which is such a soothing sight to the eyes, as I said, Swachh Bharat, Professor Satyamurthy said that it has transformed from being in the backwaters of the region, once tucked away behind the industrial area of Mohali, to becoming the gateway to the entire region, covering 3 cities and 4 states. It is truly, truly possible today, and it is indeed today. IISER Mohali is a rising star that continues to rise. Now, a question in everybody's mind now may be, what will be the future be like? It's very simple. We'll continue to grow and thrive and to do well, to do the best, to do very well, better than any of us can currently imagine. Whatever I do on a day-to-day basis, as a director by designation, I pledge to do with only the very best intentions in mind for all of our IISER's stakeholders. I assure, I mean, I shall do my best to help you to bring out the best in yourselves as teachers, researchers, and colleagues. I shall encourage you to never give too much attention to that which is negative within you. Everyone has the potential for being positive. All are very important, starting from sweepers to directors to ministers to everybody. We are equal responsibility, equal opportunity, and also for being negative within themselves. My approach will be to always maintain a positivity of approach. I may highlight that I am for you and with you always, round the week, round the clock, and wish to be accessible to all of you as and when required. I might disagree with some of you in some of the things you discuss on some days, for no group can ever agree or be unanimous about everything. However, we will decide that jo beet gaya, so baat gaya, and on the next day we'll start afresh, anew, issue by issue, discussion by discussion, resolution by resolution, decision by decision. We'll never give up. We'll take our IISER forward and forward. There are some things which are best done democratically. Others are best not left to democracy. Together, we'll find the golden mean between democracy and directarchy, sort of like a monarchy. Just a joke, just jokes apart, if you don't mind, if you allow me to proceed further. This is because I firmly believe that true excellence can only be achieved by striving for overall excellence and by encouraging everyone to do their best, and not by encouraging only the few sparks of excellence that glow in isolated pockets initially to do even better. If some are encouraged to excel while others are allowed to languish or wallow in disgruntlement or despair, or especially the despair of envy and diminishing confidence and hope, this brings the entire system down. I have seen enough of life to know that any group of human beings can truly achieve greatness only by taking along as many of their contemporaries as possible in the same direction and with the same or similar goals. Friends, therefore, if you all not go along with me sometimes, I assure you, I will go along with you, and I must. Where I can, and where the rules and guidelines of the government and the ministry and the institution do not expressively forbid it. At other times, I'll try and make you go along with me, even if you disagree. Life is about give and take, with a net movement in the desired direction, carrying along as many people as possible. I would like as many people as possible to be on the same page with respect to important things: the director, the deans, the heads, registrar, and all of our administration, as well as the faculty and the remaining non-teaching and my dear students. Here I would like to quote from the poet laureate, beloved Rabindranath Tagore. He wrote, "Oh my unfortunate country, you have not respected the light that glows within each one of you. You have insulted and humiliated your own brethren, and keen when you thought that they were not as good as you. Now, therefore, As a consequence, even the highest amongst you will have to become equal to the least amongst you, because you have considered some to be lesser than you. So if you allow, kindly agree, if I am allowed to utter what he wrote in Bengali, his mother tongue, my mother tongue, হে মোর দুর্ভাগা দেশ, যাদের করেছ অপমান, অপমানে হতে হবে তাহাদের সবার সমান. Similarly, amongst the English, a common saying is that the weakest link breaks the chain. Thus, we are urged to try and see that the weakest link is also quite strong. In chemistry and biochemistry, the well-known saying goes, from my pre-university days, the slowest step determines the rate of the reaction. We used to popularly call it RDS, rate determining step. Thus, we are urged to try and see that for the reaction to be fast and productive, attention is given to improvement of the smallest and most insignificant seeming step. In biology, similarly, an organism may be as small as possible, like virus or bacteria, is able to grow only when all of its enzymes have temperatures and pH values of optimal function that have evolved to be reasonably close to each other. The meaning of all this is that we have to work to facilitate everyone's research, teaching, and happiness. Respect each other's work equally, then only someone will get respect. This doesn't mean that we cannot pay special attention to some people at some points of time. Of course, different people require different kinds of support at different times. Sometimes the best support is to prod one into the action. At other times, the best support is to leave one alone. Sometimes the car has to use front wheel, drive to pull, and sometimes it has to use the rear wheel, drive to push. As long as everyone knows that the institution cares and will eventually pay attention to everyone, and no one feels neglected or insignificant, everyone can end up putting their shoulders into the task at hand. This is what I would like to try and have happening at IISER Mohali, all for one and one for all. Of course, the teaching and non-teaching staff will be here the longest, 20 to 30 years average per person, while the students will spend between 5 to 10 years depending on the courses they take admission into. The student body is larger in terms of numbers and also more transient in its existence here in terms of individual personalities and their influences, but the students are also very important as a group. In fact, in many ways, the students are the reason for IISER's existence and glamour and glory, but here we speak of both the undergraduate students and the graduate students, PhD scholars, postdocs, and project assistants. IISER Mohali would like its students to grow up in every way possible in studies, in play, in culture, and especially in the understanding, appreciation, and practice of science, a complete human being, as well as the philosophy of science and the ways of science, curiosity, questioning, practical experience, all of that. However, of course, with some things one must draw the line. The primary role for student here is to study and to learn to become well-educated citizens of the science endeavor of this country, as well as fine distillates of exemplary human beings. I underline human beings. The students must remember that this is not a typical university, for it is an equal parts a teaching institution and a research institution, a true amalgamation of both. One that is funded almost entirely by funds from the government of India and governed to a large extent by the rules and guidelines of the government of India, of course, with a certain degree of autonomy, which is we have to follow. A few days ago, our registrar used the following words I heard while expressing his appreciation of things at IISER Mohali. He said, quote, freedom with accountability, unquote, which I truly believe since I started my career in South Campus, Delhi University, 1988 November. This applies to all of us, students, staff, and faculty. Therefore, the students here, like the faculty and staff here, cannot be like the students, staff, or faculty at any typical university. I humbly remind. Here we are all uniquely privileged and being funded to do what we anyway like to do. We have enough degrees of freedom. We have to bring much more intensity to the real activities for which we are here, maybe at the cost of other things and sacrifice to a great extent. We all will continue to do everything possible to make students and faculty here excel in science and to look after their other needs to the extent possible while attending to the satisfaction of all, including the non-teaching staff. Finally, I would like to say one or two words about the need to also look at the applications of science. Any good scientist likes to keep one eye open for applications of the discoveries and inventions in his or her lab. IISER Mohali is a fertile ground for everything, including we are fortunate to have already established a technology business incubator. I'm very happy to know TBI. I urge as many of you as are ready to be seriously considering engaging with their TBI at IISER. Well, friends, I have spoken for quite some time. I think that I'll stop here by urging everyone to contribute to the eventual exaltation of all stakeholders at IISER, some early, some later, some a little more, some a little less. I don't mind, we don't mind, but with the best possible compromise between the championing of individual effort and enterprise and the common good of all. So, comrades, here are 3 mantras which I would like to follow and implement. First is wisdom, second is strength, and third is the courage with honesty, with utter honesty. And if you don't have our personal agenda, peace for personal agenda, peace for performance. I am very confident if somebody has zero personal agenda, he or she, no matters, whatever capacity, he or she will do the best, no doubt about it, which I have already witnessed in my limited career, my academic career and personal career. So, I am pleased to confess and submit that the place I consider to be the place of my third birth, which is the South Campus of Delhi University, when I considered the way it came into light almost in 10 years since September 1985, I witnessed all this fast as a student migrated from IICB Kolkata, a CSR institution, then as a lecturer beginning in November 1988 and then until today. And when I look at the way today our IISER aim has come up, I feel very, very confident to sail through, if at all, with all of you, if you kindly help. Thanks so much for this unique privilege vested on me by our Honorable Government of India and your kind patience, love, and attention. With these words, friends, I will request our Dean R&D to have the annual report released and also to introduce our honored speaker today, Dr. Madhavan, Nair, Rajeevan, who will talk to us today about one of the most contextual of today's topics, our Mother Nature, atmospheric physics, and climate. Thank you so much, and I wish you all the very best. Namaskar.
Thank you very much, Professor Sakar, for your words of encouragement. I'll now request our director, our registrar, and our chief guest of today to release the annual report. And after that, I will have the pleasure and privilege of introducing Dr. Madhavan Nair Rajeevan. Ladies and gentlemen, it's a privilege to introduce to you our Foundation Day lecturer, Dr. Madhavan Nair Rajeevan, whose contributions to our current understanding of monsoon variability and to the prediction and analysis of climate data are very well known and also very highly regarded, as indeed are the comprehensive analysis that he has done for decades of the annual and decadal changes in the climate over the Indian subcontinent. Dr. Rajeevan has worked tirelessly to apply the insights of physics to subjects in the atmospheric sciences, such as cloud radiation interactions, land surface processes using satellite data and climate models, prediction of mesoscale convective systems, aerosol radiative forcing, monsoon predictions using coupled models, decadal variabilities in monsoons, as well as extreme climate events like heavy rainfall, droughts, heat waves, and the like. His contributions have been published in well over 100 research publications. Dr. Rajeevan has been a recipient of the 2001 START Young Scientist Award, the 2001 Mawsum Award of the Department of Science and Technology, and the 2007 Young Scientist Award in the Atmospheric Sciences, which is given by the Ministry of Earth Sciences. He is a fellow of the Indian Academy of Sciences, the Indian National Science Academy, and the National Academy of Sciences, India, as well as a member of the International Academy of Astronautics. He's also an advisor on climate services for the Commission on Climatology, the CCI, of the World Meteorological Organization, a member of the International WCRP CLIVAR, which is an organization of the United Nations, Asian Australian Monsoon Panel, the AAMP, from 2007 to 2012, and he's the chairman of the Council of the Regional Integrated Multi-Hazard Early Warning System, which is called the RIMES for Africa and Asia. He's also an expert consultant to several councils and committees of the World Meteorological Organization. And before taking up the secretaryship of the Ministry of Earth Sciences, Dr. Rajeevan has worked for long years in the IMD, the Indian Meteorological Department, as a physicist applying the principles of physics to atmospheric sciences. Amongst the multifarious interesting applications of his work, the prediction tools developed by him using hybrid dynamical and statistical methods for prediction of thunderstorms and associated lightning over the Sriharikota rocket range of the ISRO, the Indian Space Research Organization. The methods developed by him are routinely being used as an input during launches of rockets from the Shah rocket range. With these words, I would like to invite Dr. Rajeevan to deliver the Foundation Day lecture.
Hello. 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 Hello.
Thank you. Thank you very much. Thank you very much, and I'm extremely happy to be here. I should thank our director as well as Registrar for inviting me to attend this Foundation Day of this prestigious institute, IISER Mohali. I was knowing the work being done at IISER Mohali for a few years, at least last couple of years, So I'm extremely happy to be here and to talk to you regarding the work being done in our Ministry of Earth Sciences. I represent the Ministry of Earth Sciences, and so what I will be giving as a talk here is basically what we are doing as a science. Of course, we do basic research, and unlike other departments like Department of Science and Technology or Department of Biotechnology, we have different kind of mandate, and we provide services to the nation for different sectors. And so our basic science research is not very high when compared to DST or DBT. We provide services, so we do R&D activity to support our services, to improve our services. And so we also, of course, we have an R&D program which we support different research institutions on different topics of earth sciences. So I will briefly mention all these activities, and so in between, if you have any questions or if you want me to elaborate some details, I can always do it. So what I will be doing for the next 40-45 minutes is basically describe the details of what kind of work our Ministry of Earth Sciences is doing. And okay, yeah. So what? Hope this is working. Am I audible? No. Okay. So Earth system science basically is a holistic science which covers we have in the Earth system we have 5 spheres we call atmosphere, and which we know very well, hydrosphere, which is nothing but ocean, rivers, water, ponds, etc., lakes, etc. Cryosphere is nothing but the ice and snow, and lithosphere is the hard earth core, and biosphere, basically biota. And all these 5 spheres comprises, joins together as we form as earth science, earth system. And the earth system science is basically the science comprised of all these 5 components. And the interesting part of these 5 components is it's an interactive process. It's atmosphere interacts with ocean interacts with the atmosphere, and cryosphere interacts with the atmosphere, and also ocean, for example, sea ice, interacts with the atmosphere. So there's a mutual interaction between all these components, of course, on different time scales. Atmosphere responds very quickly, ocean responds very slowly, cryosphere responds very, very slowly. So the time scales of response and interactions are different, but they do interact each other. So then our whole Earth climate system, how we define is basically the interaction of all these 5 components. So our Ministry of Earth Sciences deals with all these 5 components. So we have a component for atmosphere, we have a component for ocean science, hydrosphere basically, and we have a component for lithosphere, core earth studies we make, and we have studies on cryosphere. We do little work on biosphere, and Ministry of Environment and Forest is more inclined to do a lot of work on forest and biosphere. So we don't do much work on biosphere, but we do basic research which is related to biosphere to understand how the biospheric processes happen and how they interact with other spheres to make the climate system existent. And so these are the mandate of our ministry. As I told, that it is not a pure R&D ministry, it is a kind of a service ministry. We provide services, and so we design our own programs and we implement ourselves. We have 10 institutions in our ministry, and all these 10 institutions work together to implement these programs. So for example, we provide weather, climate, ocean and seismological services for the public safety as well as socio-economic benefits to the nation. And also we explore oceans, all the oceans, especially Indian Ocean, for generating water, energy as well as minerals, and development of ocean technology. We develop a lot of ocean technology relevant for our programs. And we also explore 3 poles, both Arctic, Antarctic, and Himalaya. So Himalayas we call the 3rd pole. So we explore all these 3 poles and understand how the 3 poles behave in the climate system. And these all programs are designed by focusing again socio-economic benefits and implement mostly in mission mode approach. Now these are the 10 different institutions we have. India Meteorology Department, which you all people may be knowing because of their weather forecast, is one of the part of our ministry. And weather services, as you know, that we provide weather forecasts as well as weather warnings to different community. For example, it is basically used for agriculture, aviation. You may be knowing that for any aircraft to take off or to land, they need meteorological weather forecast, weather information, which we provide. So at all the airports in the country, we have an office. MOES has an office. They provide all the details to them. And also we provide details for water resources, power, tourism, pilgrimage, sports, energy, etc. So these are different kinds of sectors. We, for agriculture is very, very popular weather services which we provide from the ministry. We provide a 5-day forecast for the agriculture, and we provide so-called agro-meteorological advisories, we call, to the farmers, and they take decision on their agriculture operations, day-to-day operations based on our forecast. At present, about 20.6 million farmers are getting our forecast through SMS. Now, SMS is the very cheap as well as very effective communication system. So we send the forecast through SMS in addition to, of course, All India Radio and newspapers, etc. But that number is very small. And that we will be bringing up to maybe 40 million now by the end of this year. We have almost 94 million farmers, active farmers in this country. And we also provide warnings for cyclone, tropical cyclones, and heavy rainfall, for example, the rain which we experienced in Bombay recently, and also heat wave. Heat wave is very common in this country, especially in northern parts of the country. We also provide forecasts or advisories for thunderstorms and lightning. And I am very sure that you are aware about the names Philin, Hudhud, and Varda. These are the tropical cyclones which formed over Bay of Bengal and crossed different coasts of India, and we could give accurate forecasts about 5 days in advance. So the Philin, for example, that crossed the Orissa coast in 2014 was one of the most severe tropical cyclone ever formed over Bay of Bengal. And it is a similar kind of system. It formed in 1999. You must, I don't know whether how many of you are aware about the 99 super cyclone over Orissa, which killed more than 10,000 people. So Philin was almost the same intensity. It's a very intense system. And when Philin came, the casualty was less than 10 people. So 10,000 people died in 99, 10 people died in 2014, mainly because of our accurate forecast which we could give to the state government. Of course, state government responded very effectively. That's also very important. By giving forecast is not enough. The state government has to immediately respond and have to vacate the people, have to take actions on different ways of doing it. So they did extremely good job. So Orissa state government did extremely good job by getting our information, and they saved a lot of people. And that's a very, very important highlight of our services. And also we provide services for heavy rainfall forecast we give. At present, we have the skill of about 2 to 3 days in advance, we will be able to give a good forecast for heavy rainfall, which, for example, the Bombay rain, which we experienced very recently. And also we recently started heat wave forecast. Heat waves also, people die because of heat waves, especially in northern parts of the country. We are able to give kind of advisories or warnings about heat wave that next 3-4 days heat waves can be experienced at different parts of the country, and they can take action. So based on our heat wave forecast, many state government has initiated so-called the state action plans for heat waves. Especially the Ahmedabad heat wave action plan is very famous, and they started about 2 years back, mainly depending on our forecast. And once the heat wave forecasts are issued by us, they immediately take action. They immediately talk to the collector, immediately public administration is involved, immediately hospitals are sensitized saying that the heat waves is coming, so people can come to the hospital more frequently. And also schools are closed, and they provide water and other kind of things on the road. And especially people who are traveling by long distance are advised properly that you carry some water. And this kind of very, very, very important measures they take, and they try to reduce the casualties because of heat wave. So we provide this kind of services, and nowcasting is a severe weather events like thunderstorms or lightning. So I will tell you the lightning activity or thunderstorm activity will not be able to give a forecast almost some 2 days in advance or 3 days in advance. So there the skill is only some few hours before. For example, in Chandigarh, if we can say the next 2 hours a thunderstorm can happen or lightning can happen. We cannot tell you much more than in advance. Okay, and climate services also is an important component of our work. especially prediction of monsoon. Monsoon, you know, it's a bread and butter for all of us. Indian economy depends on the monsoon performance because agriculture depends on monsoon rains. And agriculture, even though the contribution to GDP is smaller, but now it's only 15 to 17%, but still it has an important effect on Indian GDP. And so monsoon forecasts are, people consider it's very important. So we provide monsoon forecasts every year, and we recently launched a mission called Monsoon Mission. The ultimate aim is to improve our monsoon forecast so that government can take appropriate action for effective action on the agriculture as well as the different sectors. Even water resources, power, all these sectors are also dependent on this monsoon rainfall. And we also do a lot of research on climate change, and which I may briefly mention, I may not go in detail. And climate change, the science of climate change is our mandate, and we don't make any policies on climate change. For example, we don't say that this is to be done, this is to be done. We only provide the scientific information based on good research, good data, and this information we pass on to the Ministry of Environment, Forest and Climate Change, and they frame up the policies. But they frame up the policy based on our inputs, scientific inputs. So we do basic science, basic research on what is science of climate change. And you must be, at least some of you may be knowing the so-called Intergovernmental Panel on Climate Change, Intergovernmental Plan Climate Change, IPCC reports on climate change. The fifth report has come last 2 years back, and the next report will be in 2018, where we discuss all the different the status of climate change and how what also the future expectations, what the future climate can be. So, and the sixth report will be coming in 2019. If you really see the last 5 reports, none of our Indian inputs have gone into the model, into the report. All these reports are based on the scientific details made by countries like USA or UK. No inputs have gone from Indian side, mainly because we don't have our own climate model. So they will accept only if you have your own model to provide the information. So we are now developing, I will give you the details, we are developing our own model. It's called, we call Earth System Model, which basically models, it's a mathematical model, mathematical as well as physics model. It comprises of all the components of the Earth system, atmosphere, atmosphere, everything, and also it takes care of the interaction of the things. And we use this so-called supercomputers, high performance computers for running this Earth system model. So one of the computers which we have it in Pune office, where I was the director a few years back, is called Aditya. It's the second fastest computer in the country. At present, its speed is over 1.2 petaflop is the speed of the machine. And we have placed the second machine this year, and it will about 7 petaflop, so 7 times bigger than this machine. And that will be coming by end of this year. So we need huge computing facilities to run this weather as well as climate models. Okay, and also this is the important services which we provide for the farmers. And also this is the forecast which we can, if you see the last few years, the skill of weather forecast has improved a lot substantially, mainly because we could improve the models, weather forecast model which we use, and also we have a lot of data. We have installed a lot of new instruments, measurements in different parts of the country, and that will be a part of the model. And so the data density has gone up, the quality of the data has gone up, the science of modeling has also improved. So everything got together, so there's a substantial improvement in the quality of the weather forecast. And cyclone warning is very famous. Now India is one of the best nation which we can provide the tropical cyclone forecast. We are comparable to any countries like US or UK in tropical cyclone forecast. And this is the typical example how the Varda cyclone, which devastated Chennai city, was predicted about 5 days in advance. The blue is the forecast, and the black is the actual. You can see there's not much error. It's hardly some 50 kilometers is the difference between actual landfall and forecasted landfall. And this is the beautiful example how the rainfall is predicted by the model. For the tropical cyclone Varda, left-hand side is the rainfall, is a satellite measured rainfall, and right-hand side is the rainfall predicted by the weather forecast models. We also, so this is one of the tropical cyclones which formed and moved to Bangladesh, and it was well predicted by our system, our weather forecast models. almost 4 or 5 days in advance. You can see there was a lot of, it's not a direct track, it was a lot of recurvature, it was recurving, but it was well captured by the model. So initially the forecast was to the cyclone system will land over Tamil Nadu coast, then we advised the government not to take any action because it was by the model was showing very correctly that it will be recurving and it will be going over Bangladesh. And this heat wave forecast, which I told that this is the forecast which we introduced very recently. And the important activity which we do in atmospheric science is the climate modeling. And these are the, for example, if you take an Earth system is concerned, these are the different components of the Earth system. So if you want to develop a Earth system model, we have to really model all these components: atmosphere, hydrosphere, and geosphere, basically lithosphere, and cryosphere as well as biosphere, and also their mutual interaction. And for example, the solar radiation is the basic driving force for the climate system. That will pass through the atmosphere, then it will fall on the surface, that will heat up the surface as well as the ocean. Then ocean, there is evaporation, the evaporated water vapor will be flowing, will be moving, and will be forming, clouds will be forming, and the aerosols are the part of the cloud condensation processes. So all these physics also are to be modeled in the Earth system model. So it's a very complicated system, and the model also is very complicated. But however, we do make some approximations to simplify the equations. So I will not go in very detail, but I will briefly tell you how we do it. I'll skip this. So what we use is we use very simple equations, where these are basic equations. Basically, it's a conservation of momentum, mass, and energy. These are the three equations we use. And three equations for basically Newton's second law, F is equal to ma, but we put it in a differential form, and conservation of energy and relationship between PV and T. These are the simple equations we use. And in a differential form, these are the equations. And these are nonlinear differential equations. If we don't have analytical solutions, we solve it using numerical methods. There are two methods we normally follow: is a finite grid method or spectral method. Either of these two mathematical methods we use to solve this equation. In this equation, mathematical dynamical process is it's not very simple, but it's also not very difficult. The standard methods are available for numerical solutions are available. So we use a huge computer to solve these equations. But what is very important is the term Q here. We call it is a harmless looking term is Q, but the Q is basically the physics of the whole climate system. It treats how the atmosphere radiation, solar radiation comes through the atmosphere, how the long wave radiation goes from the surface of the Earth, how a cloud forms, and how cloud precipitates it out, different kinds of precipitation. In some clouds don't precipitate, don't make rain, some clouds make heavy rain, some clouds make very little rain. So all these processes are to be modeled. So that's a physical, we call it a diabetic term, and that involves a lot of calculation. So if you really take 100 hours of model calculation, 80 hours are spent only to calculate the Q term and physics term. And what are the physics term here these are the physics term, because these are all physical processes which occurs in the system, and all this start to be modeled. And so, for example, solar radiation, aerosols, and interaction, clouds, land surface process, heat fluxes will come on the land surface, and how the soil wetness is coming into the picture, how the snow forms, how the snow is melting, and sea ice, how the sea ice is forming, especially in the northern hemisphere, in the polar region, how the sea ice is forming and how they are melting. All these processes are to be modeled in the model. And this is the computer which we use, 1.2 petaflop speed machine. And we have now the second version of the Earth system model, which we developed at the Indian Institute of Tropical Meteorology in Pune. And so we started running these models to develop the future climate change scenarios. We know the global warming is happening and climate is changing. Now the question is, we also know from the past data how the past climate has changed. We know very well, Earth is warming up, so India also is warming up. We are getting more frequent heat waves and more frequent floods and more frequent heavy rains. These are all the absurd features of the climate system, which we got it from our own data. And the question is, in the future, what will happen? So that can be told only by this kind of climate models. You run the model with a kind of scenario in the future. The scenario in the future is, these are all, the climate is changing mainly because the changes in the greenhouse gases, basically carbon dioxide, methane, nitrous oxide. These are the three important gases which causes the global warming. So now we know how much is emitted, how much carbon dioxide emission, how much methane emission, how much is the nitrous oxide. In the future, we don't know how these three emissions will be. So that depends upon how the countries behave. Whether how the country's economic measures, how the industrial activities. So for these activities, we make three kind of scenarios. One is business as usual. That means no country makes any efforts to cut down the greenhouse emissions. Business as usual. You burn the coal, petrol, whatever it is as is going today, it will go on in the future. This is called business as usual. Then you put very common measures to restrict the carbon dioxide methane emission. The third process is very serious measures. You drastically cut down the emissions of carbon dioxide, methane, and so there are three scenarios, and each scenario we can prescribe in the model how the carbon dioxide will change, how the other greenhouse gases like methane and nitrous oxide will change. Once you prescribe these changes, we can really prescribe, estimate how the future climate will be using these mathematical models. And which we do, and we already done some simulations already, so we know very well what will happen in the next 30 years or 50 years, and so that projections will be very useful for different ministries to understand. For example, now in 2030s, because of the changes in the climate, what will be the effect on agriculture? Agriculture is very much dependent on the climate system, weather and other systems. So they need to understand, because of climate change, what could be the effect, whether it's an adverse effect or it's a good effect. Similarly, water resources, how the rivers will flow, whether less water will flow or more water will flow, how much is the evaporation from the river basins. So these are the things importantly which we need to understand, basically to understand. This we call as impact studies. Impact studies, we should know the future scenarios of different climate systems. So that we generated now, and I will tell you this. So, and also this very high resolution data we generated, it's at 50 kilometers. Every 50 kilometers you can get an information over the Indian region. And this data are freely available. Anybody wants to understand how the future climate, you can easily download them. It's free of cost. You can download from this website, and you can make use of for your studies. And some few examples, I'll tell you how future temperatures will go from 1960. This is the observed data, black data, and from here we started simulating. And these are the three different scenarios which I was mentioning. If you assume that the business as usual, then this is the red. So temperature by 2100 will go up to 5-degree warming. From the present day temperatures, 5-degree warming can be expected. And 2.5 degree for this middle level is kind of a balanced emission level which we can expect, and if you put restricted conditions, then it will be about 1 degree or so, a little more than 1 degree. So this is the temperature. So not much changes in the monsoon rainfall, in the annual rainfall. Rainfall will be almost more or less same. And but there are two important things happening. The cold nights will decrease. We'll have less and less cold nights, and so winters will be less harsh, and we'll have warmer winters in the future. And but warm nights also, it's increasing, but the warm nights as well as warm days, there's a substantial increase in the days, frequency of the days. So we'll have more and more warm days and more warm nights, but less cold nights and cold days. So these are the simulations made by this model. And another experiment which we started, this is basically an observational campaign which we started, is called cloud seeding. When rainfall doesn't occur, many state governments say that whether we can really artificially seed the cloud, artificially enhance the capacity of the cloud to precipitate more. So clouds are there, but it's not raining. So whether you can go to the cloud and seed it, artificially seed it, and whether you can generate more rainfall, or especially when drought occurs, they normally do it. So that people have been doing it. They hire an aircraft, go to, and they put some silver iodide, salt and all, and to try to generate more cloud. So for cloud to form, you need a cloud condensation nuclei. It's nothing but aerosols. So if you put more aerosols, we have the feeling that more and more clouds, droplets will form, and rainfall can be increased. And many experiments are being done. It's very expensive because you need aircraft to go and put it there. And so people do it, but some people claim that it's a very successful experiments we do and we can really enhance the rainfall. And some people say it's not very successful. So we started a campaign in our institute, from our institute at Pune, to understand the cloud seeding experiment, whether really what is the science of cloud seeding, whether it will be a successful measure, and also whether it's financially it is viable. For example, you spend 100 crore and you get a little water for which you can drink only you can be used by only some 5-6 people, there's no meaning. And so if it's really useful, it should be financially also, it should be viable, and also it should be a good science should be. So we want to demonstrate what is the science of cloud seeding in this country. And that can be a kind of a protocol, or that can be a kind of guideline for all the state governments to follow. So this will be starting from this year, we'll be doing for 3 years, and it's about 200 crore project, and we'll be hiring an aircraft, we'll be also buying radars, because we need to really validate the radar with the radar data. We need to validate how clouds are increasing or not. Okay. Another experiment which we started 2 years back was to understand the fog process over Delhi city, Delhi airport. You know that every winter, flight takes off from Bangalore, it doesn't come Delhi, it goes back to Bangalore again, or it lands somewhere else, because especially the fog. And the frequency of fog over Delhi city is increasing. So every year you get, instead of 10 days of fog, you get 20 days of fog, 30 days of fog. And that really disrupts the whole aircraft operations. And not only the problem with the people who are traveling, it's money, because the people spend a lot of money. The aircraft has to spend a lot of money. Instead of going to Delhi, they go to Jaipur, then they land there, then take off there again after a few hours. So it involves a lot of money. So unnecessary waste of money is involved. So they are worried about whether we can really predict fog before a few hours, so that before, for example, aircraft is coming from Chennai, supposed to land over Delhi in 2.5 hours. If there is a thick fog is going to happen by the time the flight comes, we can tell them, don't take off from Chennai now, you wait for 2 hours, after the fog goes, you can start landing. So this is the kind of inputs which they want. So we started this campaign, and I'm happy that IISER Mohali also is involved in this campaign, which we do it from November to February, and Dr. Vinay Sinha is involved. So he also put some instruments. And so this experiment will be conducted again this year. So we'll have a better understanding how a fog really happens, the science of fog, and whether we can really predict it. Understanding is better, okay, but we need to really predict, so that aviation people, airport people can use that. So we have fog prediction model, which are not very fine-tuned. And so with these observations, we do hope that we can improve the fog prediction models by tuning some kind of physical processes in the system. So that is the highlight of this experiment, which we will do again this year. And ocean services, if I am crossing my time limit, you can just warn me. Yeah. So ocean services, as you know, ocean is also an important part of the climate system, important component of the climate system. So we need to understand what is the ocean process around our seas, as well as seas in different parts. And so we put a lot of instruments over there to measure the ocean parameters. So, and putting in observations over land is much easier. So you can go there, put it there, and you can also maintain. Putting observations over the ocean is a very tough job. And also maintaining will be very difficult, because you cannot frequently go there and do this, maintain the instruments. So it's a very tough job, but we do maintain a lot of instruments over the ocean, which are very expensive. And for example, these are our data buoys we call. Different parts, of course, the frequencies, the number has gone up. And also we have a tsunami buoy locations. You can see that this is these buoys are we put up after the famous 2004 tsunami. And these tsunami buoys will help you. For example, if a tsunami happens here, the wave will come from here and it will cross across these buoys. And the buoys can immediately sense that the wave is coming, because the whole seawater will go up. And it can be immediately measured by these buoys. And these data are linked to satellite, and we can immediately get, within few minutes, few seconds, we can get this data over Hyderabad office, where we issue a kind of alert or warnings to different people. This we established very recently after the famous 2004 tsunami. And also we have different kinds of ocean buoy system. We have different kinds of systems over the ocean. Another system called Argo floats, which basically a kind of a cylinder which goes down, and stays there for up to 1 kilometer. And after a few days, observations comes up. And once it comes up to the surface of the ocean, it relays the data, whatever it measured, to the satellite. Then again, it goes down. So it's called Argo flows, and we have, of course, this will be drifted because of the ocean current. You can drift this and this side. But this ocean observations based on Argo floats have really revolutionized the science of ocean science. And it has given a wealth of ocean data, and these are all being used extensively by our scientists. And this is if you really see all the observation system, this will look like this. It's a very, very crowded observation system over the Indian continent. Of course, we have practical problems that fisherman will go there by seeing by observation, he will go and fine tune it, he will touch it, he will take it away. And if his net is caught by this mission, that's the end of it. They have to remove the net, so they will destroy this instrument and they will remove the net and go away. So this kind of practical problems are also there. Then of course, along the west coast of Western Arabian Sea, we have the problem of pirates, from Somalia pirates. So that's also a problem. We cannot even go there and maintain the instrument. So we have this kind of practical problems, but we do maintain because these observations are very, very useful for our understanding of climate system, also used for weather prediction as well as for climate prediction. And we provide our own services called potentially fishery zones. And potentially fishery zones we use basically the fishermen, early days they used to take a boat or take a small ship and go there. And they don't know where to really go for catching the fish, because they don't know where the fish will be more. And our understanding is the fish will be more, the density of the fish will be more where the water is cold water. And also there's a lot of activity, biological activity. So we use two parameters, sea surface temperature, where from there you can understand whether the water is warm or cold, and another is the chlorophyll. So these two can be measured using satellites. So we use this data and we give the forecast to the people, fishermen. For example, a fisherman going from Chennai coast, we will tell you move northwest direction 200 kilometer at this speed, and you can go there and catch the fish. You will get plenty of fish there. So this kind of potential fishery zone advisories we provide, and fishermen are extensively using it, and they are making a lot of profits out of it. And advantage is that they need not wander here and there and burn the petrol in the diesel in the boat, and also they will get more fish. Return will be very, very high. So it's very useful services which we provide. So again, it's basically a good science, good satellite technology which we use. And another is ocean state forecast. Ocean state also many ships are plying, and they need different kind of advisories for different activities that we provide. This is the tsunami warning system, which I told that we established after 2004 tsunami, and it's one of the best in the world now, tsunami warning system. And we have been issuing tsunami alerts, and also we have been measuring this tsunami system. And the highlight of this is we never issued after the 2004 tsunami. You may be knowing that no other tsunami came. But all other tsunami warning systems, for example, they have it in Australia, they have it in Japan. So they frequently do a kind of false alarms. That means they issue alarm that the tsunami is going to come, but tsunami don't come. This is called false alarms. False alarms are also not good, because once you give an alarm, then people have to be vacated physically. And so in India system, the false alarm rate is very, very small. It's almost nil. We never issued a false alarm. And so that's a highlight of our tsunami warning system. And this I will skip. And we also provide search and rescue aid tool. For example, an aircraft going into the sea, and they want to know where the aircraft has gone, or any other thing. And for example, ship has sunk, and they want to know where it has sunk. So we have a search and rescue aid tool, which is basically nothing but if something fallen on the ocean, it will go along with the ocean current. So we can model the ocean current depending on the initial conditions. Then we can tell them it must have gone to this side. So we can exactly be not able to locate, but at least the area we could locate it. And also the Chennai oil spill, we must be remembering a few months back, there was a big oil spill over the Chennai coast. Two ships collided, two oil tankers collided. A lot of oil was spilled out, and we could give a kind of advisory of how the oil spill will spread along the Chennai coast, which is basically a mathematical trajectory model we use to provide this kind of services. And this I will skip. And we also do a lot of marine biotechnology, and we have a new system called open sea cage culture, which we are doing off the coast of Tamil Nadu as well as Andhra Pradesh, where is off coast of about 5 kilometers from the coast, and we make an artificial cage and we culture the fish. And we get a lot of output from there. It's going to be commercialized. More and more commercial activities are going to happen because of this technology. And also, marine pollution, we are also worried about pollution. So not only over the land, even coastal places also is getting polluted. The coastal cities, coastal places can be polluted by two ways. One is from the land, through the rivers and etc. Or people going to the beaches, they can pollute. And also from the sea, the ships plying on the sea high seas, they throw all the waste in the sea. Ultimately, it will come to the coast. So we are trying to monitor this kind of activities along East Coast as well as West Coast. We are going to put 6 this kind of air pollution monitoring instruments there. And we will be able to also we give kind of predictions how the water quality will be. So because people will be, especially on the coast, the beaches, people will be going to the sea, they will be using seawater, swimming, etc. So they want to know what is the quality of the seawater. Really, you can literally go there and do swimming, and that will be really health hazards. So this kind of forecast we want to generate. We are already having an experimental basis, we are doing it over Madras coast. And we also do a lot of services on ocean survey and resources. Ocean has a lot of resources and plenty of resources which we are not tapped. And for example, at least over the whole globe, only 5% of the globe is explored. 95% of the ocean we are not explored. Nobody has explored. It's a huge system, and people say that we know more about our moon than our own ocean. So we have all the countries are putting a lot of money into exploring oceans, because oceans have a lot of resources like both living as well as non-living resources. I will briefly describe what we do for this kind of activities. One is this we have an exclusively economic zone, is called IISER. It's about so that is to be surveyed, because that is our basically the wealth over the country. So that is being served, and it is very difficult. And in the ocean, you cannot use electromagnetic radiation, doesn't pass through the water. So you use only acoustic system. It's only acoustic system which we can use. So sound wave, just go there and they get reflected and measures the difference, and that is being used for acoustic system to understand the topography at the bottom of the sea. And that is being surveyed. That is very important for us, all of us. Another is a concept called Continental Shelf. I don't know whether air science people are here, people who understand about core Earth. They know Continental Shelf, nothing but the whole Indian continent goes down under the water. And so the Indian continent spreads under the ocean, few kilometers away from the coast. And as per the UN laws, as per the laws of United Nations, some of this land can be it's called this Continental Shelf we call, can be owned by us. Okay, so but there is a definition, how much you can own, because it can spread even hundreds of kilometers away. So they have a limit. So basically the sediments, we measure the sediments, and the sediments should have come from an Indian land to that region. So we have to prove that up to which, for example, 150 kilometers we go there, and that sediment, we should prove that belongs to Indian continent. Okay, and the sediment depth should be 1 kilometer. So we do a lot of work to understand this kind of sediment. We take the sample and measure it and do all these chemical properties. And there's an organization called International Seabed Authority. It's a UN body. So we have to file a request saying that this continental shelf land should be given to us. So our claim is already pending with them. So probably by next year we'll get some kind of response. And once we have that, if you really get that land, that will be much more than land we have already. Okay, the continental shelf will be much more than what we have land. So so then we have full freedom to make use of the bottom of the sea, but not the top of the sea. Water column you cannot use, but bottom can be used. Now, the bottom, sea bottom, we have so-called minerals, so many other precious metals, etc., which we can explore and also exploit the things. Okay. And another is non-living resources. The ocean bottom contains many minerals, very, very many minerals. One is polymetallic nodules, we call polymetallic nodules. Another is hydrothermal sulfide. Hydrothermal sulfide is nothing but it's a volcano vents in the bottom of the sea along the ridges. and that contains a lot of precious metal like cobalt, nickel, even titanium, even gold. And so again, International Seabed Authority has given some kind of prescription. You cannot simply go there and explore any parts of the ocean bottom. And so we have been given a land 75,000 square kilometer over the central Indian Ocean for exploring the minerals over India, for our country. So we have been, last 10 years, we have been doing this experiment. And at present, there are no laws allowing any country to exploit it. So that deep sea mining cannot be done now. There is no law. And probably by another 5 years or 10 years, law may come. But we should know how much minerals are there in the spread and how we can really take it out, deep sea mining, and take it out and process it and make use of it. So we have done some experiment. We identified the area. We identified what is the process to be followed, and we did some experiment to take the polymetallic nodules, take it out to the bottom of the sea, and process it using the CSIR lab in Bhubaneswar, IMMT, and that the laboratory already designed a kind of a process to process these polymetallic nodules. And now if you really want to commercially process it and expand these activities, we need to develop the deep ocean mining system, which at present no country has. So we are now, as far as the ocean technology development, we are developing the deep sea mining system so that we can go to the shape and put the system and take large samples of the polymetallic nodules, bring it up to the bottom, the top of the ocean, then take it to the laboratory and process it. So that's a lengthy process which we are working. Probably another 5 years we will be perfecting that technique, and also we'll have a commercial system to exploit the minerals from the bottom of the sea. It's a huge amount of money is involved. So this kind of technology development also we have an institute at Chennai. It's called National Institute of Ocean Technology, NIOT. And if somebody is interested to go there, we can always arrange that. That institute is involved in developing many very different kind of technology for ocean exploration, as well as, for example, we have developed a soil tester, remotely operated vehicle. We can go up to 6,000 meters, 6 kilometers, and take observations and come up. It's called remotely operated vehicle. And we have developed submersibles which can go down, automatic coring system, and now two important systems which we are not perfect. No other country also is perfect. Is a deep ocean mining system and manned submersibles. If you really want to see hydrothermal sulfates and all to really explore it, physically people have to go down, because hydrothermal sulfate is of a few meters size. And of course, it contains a lot of very precious minerals. To locate from the top of the ocean water is very difficult. So we have only indirect way of measuring it. So if we have a manned submersible, which 2-3 people can sit inside and go down and search over the hydrothermal sulfate, it will be much easier. So we are trying to develop the manned submersible. This technique is already available with some countries. For some, Japan has a manned submersible, Germany has a manned submersible, but they don't give this technology to anyone. So we have to learn ourselves. So we are trying to develop. And the ocean system, what is the problem is the pressure. If you go down, the pressure of the water. So every 10 meters, 1 atmosphere pressure will increase. So you can think of going down to 6,000 meters, how much pressure will be there. So technologically, it is a very challenging job to develop sending 3 people down in a vessel. And it's a very tough job. Okay, so the space people are going up, so we wanted to go down. So that's the same kind of things which we are trying to do it. I know we know very well it's very challenging. We don't have our own expertise on that, but we are trying to develop it. If some of you can help us, we'll be very happy to do it. Okay, and we also have a desalination plants, especially islands in the Lakshadweep Islands, for example. They don't have water. They don't have drinking water. Okay, and so they need a kind of technology where the drinking water is available. So we have installed 3 plants over three islands in Lakshadweep, which make use of seawater and make the desalination and give it to the people. And these plants now generate 1 lakh liter drinking water per day. And only initial cost was involved from us. We put the plants. And now there is no maintenance because it's a non-maintenance. It's not RO technique. It's based on ocean thermal energy. You take water from about 150 meters down and also the surface, and you, at the lower pressure, you warm it up, and the water vapor will be formed, and it will be cooled by the water from the 150 meters down. That's all. You just warm it up, water will be evaporated, the evaporated water, vapor, just condense it using cold water. That's all technique. But it's a huge technique, it's a huge system, and so you don't use RO technique, and so it's environmentally very, very friendly, and only initial investments are there. And very, very interesting thing is these 3 plants are operated by local people. We are not involved our own technicians. They themselves operated, very easy to operate, so they operated. So next 6 more plants we are now started. Another 2 years, 6 more plants will come. That will ease most of this drinking water problem of Lakshadweep Islands. Okay, and also people are talking about wind energy now. Now people are talking about generating more and more wind and solar energy for the country, and over the land it's easy to put. But also we are thinking of putting offshore wind energy turbines. That means you go for about 5 to 10 kilometers off the coast, and there you can get more wind energy. Especially there are 2 places, one is off the coast of Gujarat, another is coast of Tamil Nadu. There are 2 places where you can generate huge amount of wind energy if you really go out to the sea. So we are trying to do some experiments of going up the coast, we are putting a structure and measuring how much the wind capacity. So we have we put a kind of a bar like this. It's about 3 kilometers height, and we put this wind lidars to measure what's the speed of the winds there. So that we are working with the company called, it's basically MNRE, Ministry of Non-Conventional Energy Resources, and we are supporting, and MS Suslon is the company in which we are involved. Okay, and also we do a lot of biology. Understanding the living resources. We have an institute in Kochi, Center for Marine Living Resources and Ecology, and they go to the ship, they have their own ship, so we go there and take all this kind of species, and we also do a lot of ecological modeling, etc., for the ocean system. And also we are crazy, sometimes we make crazy projects, as this is origin of the monsoons. And as you know that India plate was not, it's a part of the Australian system earlier, many years back it drifted, and now it is drifting, it is colliding with the Himalayan thing, and Himalaya is growing. And so monsoon has come only when this Indian plate came and hit our Himalayas, and Himalayas is the important component of the monsoon system. So now we want to know really when really happened. So we have really putting 2 big holes, it's called drills, in the bottom of the sea up to 3 kilometers, and the sea depth itself is over 1 kilometer. So you go down 1 kilometer, again make a hole of 3 kilometers, take the earth core and analyze it. It's a paleoclimate studies. And this is an organization called International Ocean Drilling Program. It's a very famous international organization. We are part of that. So we did an experiment, it's called Lakshmi Basin. This part is north of Arabian Sea. So we go there with this kind of ship. It's a very, very sophisticated ship which can drill up to 3 or 4 kilometers down to the ocean bottom. And we took the ocean core, so the earth core, and people started analyzing it. Probably by next year we'll get some good results. When was the origin of the Indian monsoon? And of course, it's not very relevant for us, whether it's 60,000 years or 65,000 years. We have a monsoon now. So now these are all basically academic issue, but we are interested in doing this kind of crazy studies also. And we are now launching a deep ocean mission by this year, which will be basically working for understanding the ocean process, taking out ocean resources, and especially water, energy, and minerals. And for example, deep fisheries are not there. Deep fisheries are not at all a good science in this country, so we understand how deep fisheries can be encouraged. And this kind of, so basically supporting the Government of India initiative of blue economy, developing more and more money, wealth from the ocean. So that's the purpose of this ocean mission, which will be about 10,000 crore program, which will be, but it will be a multi-institutional, many ministries will be involved, like DST, DBT, CSIR, ISRO, DRDO, all these institutions will be involved. Geoscience, as you know that earthquakes happen in this country, many earthquakes are happening. Now we have a system called seismological observatories where we at present we have 86 observatories. With these observations we will be able to, now as you know that earthquake cannot be predicted and there is no science of earthquake prediction, but earthquakes can be monitored. When earthquake happens, immediately we can say that this place of this intensity of earthquake happened, and that immediately people can use it to go there and save the people or do some kind of measures. And so we are putting 86 observatories. With this, we are able to pinpoint and inform the people within 5 minutes of an earthquake happening. An earthquake happened within 5 minutes, we are able to locate the place exactly and what is the intensity. Intensity is more important. And we are able to communicate automatically to the different people, especially big organizations like NDMA, National Disaster Management Authority, etc., which they will immediately take further action. And this density of these observations, which we are going to increase it to 114. So the advantage of increasing that density will be to reduce the time of information. Now we are doing it within 5 minutes, we want to reduce it to 3 minutes. So for that we need to expand the activities, the number of observations which we are doing it. I'll skip this. Then also we are trying to understand whether can we get some kind of precursors to make the earthquake prediction. Earthquake prediction is not possible because we don't have a precursors. We don't know how it happens, basically. We have some understanding how an earthquake happens, but we don't have a precursors to get, so this happened, so maybe after a few hours we can expect an earthquake. This kind of linkages are not there. So we are trying to understand this earthquake process. We have launched a huge project near Koina. Koina is in Maharashtra. Koina Dam, you must be knowing. Koina Dam in 1967, they had a very huge earthquake because of, and it was told that it is a reservoir-induced earthquake. Now we are launching we already launched a huge experiment in which we go up to 5 kilometers. We put a hole, we drill a hole up to 5 kilometers and put the instruments, seismological instruments there and measure what is really happening. And after that 1967 earthquake, many small earthquakes are happening. Every year is about 30-40 earthquakes happen. But it's all small intensities of Richter scale of 3, 3.5, 4, maximum up to 4, 4.5. And so if we put the instruments, whether before earthquake happened, whether some signals are there with these kind of observations. So that is the purpose of this. So we already made a hole of 3 kilometers we call pilot hole. First we will put the instruments there and measure. Then we will make a main hole of 5 kilometers size, 5 kilometers deep. And it's a lengthy process and a lot of money is involved. And anybody wants to go and see this kind of activities there, you are always welcome. We can arrange that visit. And exploring polar region, I'll take another 5 minutes. Exploring polar regions, we go to 3 different poles. Antarctica we started in 1982, and we are one of the first countries who visited Antarctica. And now we are a member in the Antarctica Treaty, which is a very privileged status for the country. And from 1982, every year we have been going. About 100 scientists go every year, and they go in somewhere in November, and they stay back about 1 year and come back. And of course, they don't go there and sit there and come back. They do a lot of science experiments. So we involve people from different organizations like GSI, Geological Society Service of India, ISRO, many other different organizations, including military people who are doctors who wants to know how the human behavior in extreme harsh conditions in Antarctica. So they also join us. And we do a lot of experiments there. We have 2 stations. One is called Maitri, another new station called Bharati. Maitri is very old, so we are going to replace that station now. And a few people, 60 people will be in Maitri, 60 people will be in Bharati. And they will be doing a lot of experiments, including understanding the cryosphere process, atmospheric process, glaciers, etc. And we go to Arctic also. We have a station called Himadri, and that is the area owned by Norway. And so there we do a lot of experiments to understand the Arctic process. I don't know whether you are aware, Arctic sea, there are a lot of ice over the Arctic sea. The Arctic sea ice is melting. Every year it is reducing. In 2000, by 2040-50, you will see an Arctic sea without any ice. So that has of course, then mainly because of global warming. That is a beautiful example of the effect of global warming in the Earth's climate system. If somebody asks you, we are talking about global warming, can you show me an example where it is effect is seen? Simple answer is Arctic sea ice. It is melting every day, every year. And one fine morning, you will have a Arctic sea without any ice. There are a lot of economic benefits. The sea can be completely used for shipping. So people who are in the Europe, if you want to come to the eastern side of Japan, they need not come across all these places. They can go this side. Similarly, China wants to go to America. They need not go this way. They can go this side. So a lot of economic new avenues are coming. So even after 30 years, it may happen, but people started thinking of making use of these routes and making more profits. Then same way, the countries like Singapore, unless the ship comes through this Singapore industry won't survive. Their shipping industry won't survive. So they are worried, but sea ice is melting because most of the ships won't come here. So they are also worried. So India also worried to some extent, may not be through the shipping industry, but many other activities. It is strategically very important. So our presence in Arctic is very important. And there's an international institution involved. It's called Arctic Council. India is an observer in the Arctic Council. Only Arctic countries are all the members, but they have added some few countries like India, China as observers. So we have some kind of role in controlling the Arctic process, for example, the Arctic activities in the Arctic. And so we are putting more and more people there. We are trying to expand the activities. Now we are trying to establish another station in the Canada, Arctic region of Canada, and that will come up by another 2 years. So these are the Antarctica 2 stations. I will skip all these things. And there is in Himalaya also, maybe you must be knowing about glaciers melting in Himalaya. There's a lot of controversy came 2 years back. Glaciers in the Himalayas are melting. If glaciers are melting, means all the water will come into Sindhu's river, and you can get a lot of floods, especially over Bihar, countries like states like Bihar, Punjab, all this area. And then the question is whether glaciers are really melting. If so, what is the rate of melting? What's the process of melting? Unless you go there and take measurements, of course, satellite can see the glaciers because satellite technology can see the see the glaciers. But unless we go there physically take measurements, we will not be able to understand the dynamics of the glacier melting. So we have set up an observatory about this is somewhere in Himachal Pradesh. It's about 4,000 meter, and we have set up this observatory. And so all these observations started coming, and so that these observations will be used for understanding the mass dynamics of the glacier mass. And this data also can be shared with anyone if somebody is interested to use it. And I'll skip all these things. So our services help basically to save people. We save a lot of people from cyclones, tropical cyclone, heavy rainfall, floods, etc. We also provide a lot of economic benefits for the country, and yes, science services can cost. Our budget is about 1,000 crore. 1,000 crore. If you assume there are 100 crore people, and our whole services is 10 rupees per person, very cheap. Each individual charge only 10 rupees, but we provide plenty of services for the country. But our ministry charges only 10 rupees per person. And so that's the effective cost of services for the ministry. So I tell this to people because we need more and more money. We tell them only 10 rupees, we are able to provide all these services. Give us another 10 rupees, we can give you more services. Especially to our big government bosses, I tell this point. Of course, they listen, but they don't give. The services provided, each person can do timely accurate basic forecast service. Small service can be used for different sectors. We are trying to improve our services. But I'll tell you the science, especially weather and climate services science, there are a lot of errors, a lot of approximations. We know very little about weather and climate science. That's a confession I want to make. If you add physics, maths, you add 2 plus 2, you'll get 4. In weather and climate service science, if you add 2 and plus, you will not get 4. You'll get either 3.9 or 4.1, that kind of thing. So because the whole atmosphere is a chaotic system, so chaotic system has a lot of approximations we need to make for solving the equation. And so weather forecast beyond 5 days will not be accurate. So we need to provide different kinds of methods to give forecast beyond 5 days. So there are a lot of approximations. I'll tell you, it's a very challenging science. Weather and climate science is beautiful science, good physics, good maths, good chemistry. A lot of chemistry is involved, and especially atmospheric chemistry people are to be involved because of climate change, the atmospheric constants are changing, and because atmospheric constants are changing, it can affect the climate. And so it's a two-way process. Climate and atmospheric chemistry are interlinked. Because of changes in the atmospheric constraints, the climate can change, and changing climate can change also the atmospheric constraints. So atmospheric chemistry is important science, so we need to engage people, especially in IISER Mohali. I think this is my humble suggestion to director, that the atmospheric chemistry program should be engaged. Not only here, wherever I'm going, I'm trying to say that weather, science, weather, climate, and this kind of atmospheric chemistry and ocean science should be encouraged everywhere. Earth science, basically Earth system science should be encouraged. So this is my humble suggestion to all of you. And for a number of papers, we whole ministry publish about 400 papers in a year, which is not that good, because as I told you, this is not an R&D institution, so we must basically provide the services. But still we write papers, we do write a lot of good papers. And you may be knowing this man, K.R. R.K. Lakshman, and this is one of the cartoons. I was in India Meteorology Department for many years, and this came when I was as a weather forecaster, I was in IMD. I used to read it and I used to enjoy myself. I am here. This is I am. And he said, that's right, I belong to Weather Bureau, Weather Forecasting Section. How did you guess? Okay. And now, if I am, frankly speaking, if he is alive now, I am very sure that he won't make this kind of cartoons. This is with that note, I will stop here, and I wish you all the best. Thank you.
So, Dr. Rajeevan, would you care to take a few questions?
Yeah, yes, of course.
Does anyone have questions? Can we take a few? One there.
Yeah.
Thank you, sir, for such a nice talk. I mean, I wanted to ask about the climate forecast, which you said that there are representative concentration pathways where the temperature rise could be 2.5 to 4 degrees. So what would be the plausible impact on the Himalayas and the ocean temperature? So will that cause more cyclones as well? And overall assessment, I mean, can you give some insights on those results as well?
Yeah, so when the earth warms, if temperature goes up, there are consequences. There are consequences that it can lead to more. So more warmer temperature means more evaporation, so more and more moisture will be in the atmosphere. That will intensify more heavy rainfall activities. That will lead to more frequent heavy rainfall activity, number one. Number two, as far as tropical cyclones are concerned, more warm water, it will be more intense. The cyclone, when moves over across this warm water, the recent Harvey cyclone, when it is intensified, why it has become very intense cyclone, it was one of the most severe cyclone which crossed the American coast. Mainly because it moved over a warm water region. A lot of warm water means nothing but it is ocean energy. It provides you a lot of latent heat and sensible heat to the atmosphere. So it's basically energy. You drive the engine of the tropical cyclone. You put more petrol on the car, that kind of thing. So it will be more intense. So that is so any warming will intensify the hydrological cycle. That is the main purpose.
So, what are the steps being taken for the control of floods in Odisha, West Bengal, Assam and all those regions?
Pardon? I could not hear.
Sir, I am asking, what are the steps being taken for the floods that are happening each year in Assam, West Bengal, Odisha region? A lot of floods are happening there, sir.
Yeah, that's true. So government has to be. So we provide the weather warnings for flood, especially heavy rainfall for the state government people. So they have to immediately take action for. So, but they are not very sure whether a heavy rainfall will really lead to flood. All the heavy rainfall events won't lead to a flood, especially when the soil is not wet. It will, first kind of rains, it will simply go into the soil. But soil is already saturated. Any rain will come, it will come as a flood. So it depends upon many conditions. So the government is sometimes they don't take a very wise action of removing people, warning people properly. So there is a small communication gap between our forecast and as far as the action on the ground by the government. So we are trying to improve that. We are now to provide them the adequate kind of advisories saying that this heavy rainfall will lead to floods. So please take action. So that kind of advisory now we are trying to generate and give it to them.
Sir, I didn't get it how the ocean drilling 3 kilometers inside can help you get how the monsoon originated. Can you explain a bit?
As I told that the whole Indian plate has come from Australian plate. It was started moving about 60,000 years back, and now it is colliding with the Eurasian plate and Himalayas and all these things. So if you drill a very deep distance, with deep depth, and take the earth core and analyze it how the past climate, you can, so I think that is in Vinay Sinha's group, there is a paleoclimate scientist, so you can also ask him. So you have different techniques of understanding the age of that earth core.
Okay.
Different techniques are there, carbon dating, etc.
Sir, I have two questions for you. First one, there is a lot of contradictions in the forecasting of the whether it is rain or snow. Because as you said, what I get to think is that about 50% standard deviation is there in terms of the forecast of the rainfall and the snow. Very recently, we have a snowfall in Lahaul Spiti 2 days back. And what Mr. Pachauri said about 4 years back, it was all contradicted. So still, in spite of all those, yes, the things have improved in the cyclone sector, but in the rainfall and the snowfall, there is a lot of deviation. Secondly, our farmer in the Punjab and Haryana, they used to burn a lot of husk, which contributes to the benzene in the atmosphere and the particulate matter. So I would request you to sensitize them also through your SMS and all, because you you give them the warning for everything. So this has been a very particular problem in this part.
Yeah.
And what about your opinion about the contradictions in the forecast? Because in Chandigarh, for the last 20 years, they would start from June, and till mid-August they will say that monsoon has failed and it has become weak, and Mr. Sundar Kumar is there in IMT here. So basically, if you see, there's a maximum rainfall in the month of September, and although initially they forecast much rainfall in May, and as for snowfall, it is it's almost weird. I mean, it's almost a double.
You want me to respond?
If you wish, sir.
So as I told, that weather prediction is a very tough proposition. So all these days, all the forecasts may not be correct. So we have success rate, for example, next 2 days of forecast, we have success rate about 70%. So remaining 30% of occasions we fail. So that's a science of weather science.
My query is from snowfall.
Snowfall also same thing. Snow is nothing but precipitation. It's the same thing. This process is same. If temperatures are low, you will get it form as a snow. That's all.
Please join me in applauding Dr. Rajeevan for a wonderful lecture. And sir, it's a pleasure for me to begin to propose a vote of thanks by thanking you, for sparing your time. This is a very small memento. It's a mug with IISER on it. Thank you very much. It's also a pleasure to thank everyone else who's been associated with this program. That is every division of IISER, and in particular also for help with the annual report, Dr. Amit Kulsreshta and Dr. Indranil Banerjee, the engineering division, the administration, every division of IISER. Thank you very much for a wonderful program. Please join us now in celebrating the Foundation Day by partaking of some snacks and refreshments outside. Thank you. Thank you very much. Sir.
पेन ड्राइव ले लिया ना